Hello students, I am Dr. Sangeeta Sharma, your science teacher. Today we will be continuing with chapter 12 of your science book, that is electricity. And in today's video, that is part 5, we will be learning about resistance of parallel system of resistors. That is students, we will see how resistors behave when they are connected in parallel and what does parallel system means. In our previous video students, we learnt about the resistors connected in series. There the resistors were connected end to end, and here we will see how the resistors are connected in parallel and what is the equivalent resistance of such system of resistors. So students, let's understand resistances in parallel. Now, when resistors are connected in parallel, that is resistors in parallel, then here we will observe that and we will understand that the resistors are said to be connected in parallel if potential difference across each of them is the same and is equal to the applied potential difference. Now here students, we must understand that if resistors are connected in parallel, then the potential difference across each resistor is going to be the same and is going to be equal to the applied potential difference. हमारे पिछले वीडियो के अंदर स्टूडेंट्स हमने समझा था कि जब रेजिस्टर सीरीज में कनेक्टेड होते हैं यानी कि एंड टू एंड कनेक्टेड होते हैं तो उस टाइम पे हर रेजिस्टर में से सेम अमाउंट ऑफ इलेक्ट्रिक करंट फ्लो करती है. वहां पर क्या सेम था स्टूडेंट्स? इलेक्ट्रिक करंट जो कि हर रेजिस्टर में से पास हो रही थी वो सेम होती है. और यहां पर जब रेजिस्टेंसेस पैरेलल में कनेक्टेड हैं तो उनके अक्रॉस पोटेंशियल डिफरेंस सेम है और ये पोटेंशियल डिफरेंस उस पोटेंशियल डिफरेंस के बराबर होगा जो कि सर्किट में अप्लाई किया गया है. राइट स्टूडेंट्स? देन here one end of all the resistors is connected to one common point and the other end to another common point. There in series combination the resistors were connected end to end, and here what is happening that all the resistors, one end of all the resistors is connected to one common point and the other end of all the resistors is connected to another common point. Let's understand this by the figure. Now here we see that for example we have taken three resistors R1, R2 and R3. Now one end of each of these three resistors, this end of this resistor, this end of this resistor and this end of this resistor, all the three are connected to one common point A, and the other end, that is the other end of these three resistors is connected to another common point B. So here students, what we see is that these three resistors are said to be in parallel and the potential across these three resistors is the same, that is the potential across R1, R2 and R3 all are equal to V, where V is the applied potential difference, which is the potential difference given by this battery connected in the circuit. तो यहाँ पर बच्चों हमने क्या देखा कि तीनों रेजिस्टर्स का एक एंड एक कॉमन पॉइंट से जुड़ा हुआ है और दूसरा एंड जो है तीनों रेजिस्टर का दूसरे कॉमन पॉइंट से जुड़ा हुआ है और इनके अक्रॉस पोटेंशियल डिफरेंस जो है, तीनों के अक्रॉस जो पोटेंशियल डिफरेंस है वो अप्लाइड पोटेंशियल डिफरेंस के बराबर है. Now the source of potential difference is connected across these 2 points. The source of potential difference is connected across these 2 points A and B. So this is clear in this figure that these three resistors connected in parallel are having the same potential difference which is equal to V and which is same as the applied potential difference. Now students, from this battery what we get is we get a amount of current, say I. Now if I is the amount of current flowing through the circuit, then when this I reaches the point A, then here it sees three wires. At this joint the current sees three wires. So the current distributes itself into three parts, that is I1, I2 and I3. That is I1 goes from the first wire, I2 goes from the second wire and I3 goes from the third wire. So what we see here is that I distributes itself into the 3 wires which it sees at the common point A. So what we see here is that the current I1 is flowing through R1, current I2 is flowing through R2, and current I3 is flowing through R3. Now this I1 reaches point B, this I2 also reaches point B, and this I3 also reaches point B. And here at B, I1 plus I2 plus I3, which is equal to I, comes out, and we have a complete circuit. That is, the 3 currents combine at B and constitute I. So here we see that the currents flowing through the 3 resistors are not same. तीनों रेजिस्टर्स में से अलग अलग करंट फ्लो कर रहा है. तीनों रेजिस्टर्स के अक्रॉस पोटेंशियल डिफरेंस तो सेम है, पर तीनों रेजिस्टर्स के अक्रॉस करंट डिफरेंट है. तो यहां पर ध्यान रखना है स्टूडेंट्स कि पैरेलल के अंदर करंट अलग अलग होगी, पोटेंशियल डिफरेंस सेम होगा, और वहां पर सीरीज के अंदर पोटेंशियल अलग अलग था पर करंट सेम थी. So let's understand and calculate the equivalent resistance for these 3 resistors. Suppose the current flowing from the cell is I. At the point A, this current is divided into 3 parts. Suppose I1, I2 and I3 are the currents in R1, R2 and R3 respectively. Thus we have that I is equal to I1 plus I2 plus I3. This I told you that the current I, when reaches A point, which is the common point, there he sees 3 different wires and it gets divided into I1, I2 and I3. So I is equal to I1, I2 and I3. At B point, all these 3 currents combine and again give I. Let the potential difference between the points A and B be V. The potential difference between the point A and B is taken as, say, V, which is equal to the applied potential difference. Since each resistance is connected between A and B, the potential difference between the ends of each will be V. Therefore, I1 can be written as V upon R1. How did this come, student? This came from Ohm's law. Then what is Ohm's law? V is equal to IR. Now for the first resistance, the current is I1 and the resistance is R1, but the potential is same. So we will have I1 is equal to V upon R1. Then I2 will become equal to V upon R2 and I3 will become equal to V upon R3. Since from here we say that I is equal to V upon R. So we have used this formula here and keeping the V the same, since the potential across the 3 resistors is the same, then what we get is I1 is equal to V upon R1, I2 is equal to V upon R2 and I3 is equal to V upon R3. Now substituting these values in equation 1. What was equation 1? I is equal to I1 plus I2 plus I3. So I is equal to, in place of I1 I have written V upon R1, in place of I2 I have written V upon R2, and in place of I3 I have written V upon R3. So this can be if the equivalent resistance between the points A and B be R, then I is equal to V upon R. Now here students, if we take the equivalent resistance of R1, R2 and R3 which are connected in parallel to be equal to R, then by Ohm's law again what we have is that I is equal to V upon R. Let this be equation number 3. Now in equation number 2 we had I is equal to this. Now here what we see is that the left hand side of equation number 2 is I and the left hand side of equation number 3 is also I. So we can put the right hand sides equal to each other. Here we have I and here also we have I. So we will equate the right hand sides of equation 2 and equation 3. So comparing equation 2 and equation 3, what we get is that V upon R is equal to V upon R1 plus V upon R2 plus V upon R3. Now students, here what we see is that V can be taken out as common from here. So it will become equal to V 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now this V will cancel out with this V, so we will be left with 1 upon R here and the 1 upon R1 plus 1 upon R2 plus 1 upon R3 here. So what we will get is, we will get the equivalent resistance 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3, where R is the equivalent resistance of these three resistors connected in parallel. So in words, what we can write is, that is the reciprocal of the equivalent resistance. The reciprocal of the equivalent resistance of the resistances connected in parallel is equal to the sum of the reciprocals of the individual resistances. Sum of the reciprocals of the individual resistances. So this equation gives us the equivalent resistance of three resistors connected in parallel. So this was an example. We took an example of three resistors. Resistors may be 2, maybe 4, maybe more. So in order to solve the problems given, what we need to keep in mind is, we need to keep in mind this formula. This is the formula for equivalent resistance of resistors connected in parallel. So students, let's understand the main points for resistors connected in parallel. In a parallel resistance circuit, it should be noted that the potential difference across each resistor is the same and is equal to the applied potential difference. This we have understood, that for resistances connected in parallel, the potential difference across each resistor is the same and is equal to the applied potential difference. Then the current through each resistor is inversely proportional to the resistance of that resistor. Now what does this mean? This means that by Ohm's law what we have is V is equal to IR. So what does this imply? This implies that I is equal to V upon R. Now since V is common for all the three resistors, it is same for all the three resistors. So what we see is I is inversely proportional to R. That is, the current flowing through each resistor is inversely proportional to the resistance of the resistor. यहाँ पे क्या मतलब हुआ स्टूडेंट्स इस बात का ये मतलब हुआ कि किसी resistor का अगर resistance ज़्यादा है, रेजिस्टेंस ज्यादा का मतलब क्या हुआ? अपोजिशन वो ज्यादा ऑफर कर रहा है, अपोजिशन ज्यादा है मतलब करंट कम होगा. अगर किसी का रेजिस्टेंस कम है तो उस केस में क्या होगा? अपोजिशन ऑफर्ड कम होगा मतलब करंट ज्यादा होगा. सो द करंट थ्रू ईच रेजिस्टर इज इनवर्सली प्रोपोर्शनल टू द रेजिस्टेंस ऑफ दैट रेजिस्टर. मोरओवर, total current through the parallel combination is the sum of the individual currents through the various resistors. If the current through the various resistors are taken as I1, I2 and I3, then the total current is given by I is equal to I1 plus I2 plus I3. Here students, we are taking three resistors for example only. So the total current through the parallel combination I is the sum of the individual currents through the various resistors I1, I2 and I3. When added, it gives us the total current through the circuit. The reciprocal of the total resistance of the parallel combination is equal to the sum of the reciprocals of the individuals' resistances. So here we have given a formula for the equivalent resistance of resistors connected in parallel, and the formula is 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. So if we have more than 3 resistors, then we will keep on adding the reciprocals of each individual resistance. Now students, the total resistance in parallel combination is less than the resistance of the individual resistors used in the circuit. Now what does this mean? Suppose students, we have three resistances. We have three resistances say equal to 1 ohm, 2 ohm and 3 ohm. Suppose we have three resistors 1 ohm, 2 ohm and 3 ohms connected in parallel. Then the equivalent resistance of these three resistors will be given by the formula 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So we will write it over here that 1 upon R will be equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So what we will do here students is we will substitute the values. So 1 upon 1 plus 1 upon 2 plus 1 upon 3. So the LCM can be taken as 6. So here we will have a 6, here we will have a 3 and here we will have a 2. So what we see here students is that the total resistance comes out to be 6, 7, 8, 9, 10, 11, 11 upon 6. Now this is the reciprocal of the equivalent resistance. So the equivalent resistance is 6 upon 11. Now if I divide this 6 by 11, then I will get a quantity which is going to be less than 1. Now here the minimum resistance was 1. So 1, this equivalent resistance which is coming less than 1. So 6 upon 11 is less than 1, 6 upon 11 is less than 2, 6 upon 11 is less than 3, or you can say that it is even less than the minimum resistance. The minimum resistance here is 1 ohm, and what we see is that the equivalent resistance is even less than the minimum resistance of the resistors connected in parallel. So the total resistance in parallel combination is less than the resistance of the individual resistors used in circuit, right students? So when resistors are connected in series, the current through each of the resistor is the same. As we have done this in our previous video, that if resistors are connected in series, then their current flowing through them is the same. And when the resistors are in parallel, the potential difference across each resistor is the same and not the current. So students, we have to keep this point in mind कि अगर सीरीज में कनेक्टेड हैं रेजिस्टर्स तो उनका करंट सेम होगा. सीरीज में अगर कनेक्टेड है तो उनका करंट सेम होगा, और अगर पैरेलल में कनेक्टेड हैं तो उनका पोटेंशियल डिफरेंस सेम होगा, जो कि अप्लाइड पोटेंशियल डिफरेंस के इक्वल होगा. पैरेलल के अंदर करंट सेम नहीं होता. करंट कितना होता है? सबके अंदर अलग अलग होता है. फॉर हाउस होल्ड पर्पस all electrical appliances are connected in parallel combination so that they get the same voltage from the power supply line and thus work properly. जितने भी हमारे हाउस होल्ड सर्किट्स होते हैं वहाँ पर हाउस होल्ड सर्किट्स के अंदर पैरेलल सर्किट्स लगाए जाते हैं, पैरेलल सर्किट्स यूज़ किए जाते हैं, क्योंकि जो हमारी पावर सप्लाई है घरों की वो 220 वोल्ट्स की होती है, और वो जो 220 वोल्ट्स का पोटेंशियल डिफरेंस है जब वो पैरेलल के अंदर इक्विपमेंट्स को कनेक्ट किया जाता है, यानी कि सर्किट जो है वो पैरेलल बनाया जाता है, तो हर एक के अक्रॉस पोटेंशियल डिफरेंस 220 वोल्ट का 220 वोल्ट का मिलता है. तो इससे क्या होता है, जो भी अप्लायंसेस हमें काम में लेने हैं वो प्रॉपरली वर्क करते हैं. अब अगर सीरीज में लगा देंगे तो सीरीज में तो पोटेंशियल जो है वो अपने आप को डिवाइड कर लेगा, तो हमें क्या मिलेगा, हमें 220 जो है वो डिवाइडेड मिलेगा. तो इसलिए वो जो है सीरीज कनेक्शन जो है वो एक्चुअली यूज नहीं किया जाता, पैरेलल कॉम्बिनेशन जो है वो यूज किया जाता है हाउस होल्ड सर्किट्स के अंदर. यहाँ पर स्टूडेंट्स एक और रीजन होता है पैरेलल सर्किट को यूज करने का. एक रीजन तो ये हो गया कि हमें 220 वोल्ट्स हर एक कॉम्बिनेशन के अक्रॉस मिल जाता है, और दूसरा रीजन क्या हुआ कि अगर सीरीज में हम कनेक्ट कर दें और बीच में कोई फॉल्ट आ जाए तो जहां पर भी फॉल्ट आया है उसके आगे करंट नहीं जाएगा, तो इसलिए क्या होगा, आगे का सारा सर्किट वर्क ही नहीं करेगा। तो इसलिए हाउस होल्ड सर्किट्स के अंदर पैरेलल सर्किट यूज किया जाता है, ताकि अगर किसी एक सर्किट के अंदर अगर कोई प्रॉब्लम आ भी जाए, कोई फॉल्ट आ भी जाए, तो बाकी के सर्किट जो हैं वो प्रॉपरली वर्क करते रहेंगे और हर सर्किट के अक्रॉस जो पोटेंशियल डिफरेंस है वो 220 वोल्ट्स का मिलेगा। Now here students, now we are ready to solve the numerical problems based on parallel combination of resistors, and we have to keep in mind the Ohms law and secondly the equivalent resistance formula for parallel combination of resistors. So we will use these two formulae and let's solve the in-text exercises. The in-text exercises are the exercises which are given in between the chapter, and we are solving today the problems at the end of this topic, parallel system of resistors. So let's see the first problem, which is example 12.8 in your textbook. So what does example 12.8 asks? In the circuit diagram given in figure 12.10, suppose the resistors R1, R2 and R3 have the values 5 ohms, 10 ohms and 30 ohms respectively, which have been connected to a battery of 12 volts. Calculate the current through each resistor, the total current in the circuit and the total circuit resistance. Now students, here we have a circuit diagram in which there are 3 resistors connected in parallel. So let's see the circuit diagram. Now here we have R1, R2 and R3. These 3 are connected in parallel, and what are the values? The values are 5, 10 and 30. So here we have, this is say 10 ohms and this one is say 30 ohms. So we have 3 resistors connected in parallel to a 12 volt battery. So the battery potential is given as 12 volts. Now what we need to calculate? We need to calculate the equivalent resistance of these 3 resistors. We need to calculate the total current flowing through the resistors, and we need to calculate the individual currents passing through these 3 resistors. So this has been asked, the current through each resistor, the total current in the circuit and the total circuit resistance. So in order to solve this, first let's calculate the equivalent resistance of the circuit. Now students, here in order to calculate the equivalent resistance, we will take the formula for resistances connected in parallel, and the formula is 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So I will substitute the values. The first resistance is 5 ohms, the second resistance is 10 ohms and the third resistance is 30 ohms. So on taking the LCM 30, what I get is 5 6 are 30, so I will have a 6 over here, 10 3s are 30, so I will have a 3 over here, and here we will have a 1. So what this will come out to be? This will come out to be 6, 7, 8, 9 and 10 upon 30. So the equivalent resistance will come out to be, now this we can divide it by 10, so we will get a 1 upon 3. So the equivalent resistance will become 3 ohms. So now students, this is the equivalent resistance and we have a voltage supply of 12 volts. So the total current flowing through the circuit can be calculated using the Ohm's law, which is V is equal to IR. Now since V is equal to IR, this implies that the current can be calculated by dividing V by R. So V here is 12 and the equivalent resistance is 3. So the total current flowing through the circuit is 4 amperes. Now this is the answer to the C part, this is answer to the B part, and in the A part we are asked that calculate the current flowing through each resistor. Now students, here we have the three resistors. Here we have the three resistors. Now this is 4 ohms of current is flowing through it. So what we see is this 4 ohm of current is now going to distribute itself into 3 parts. Here we will have 4 ohms and this 4 ohms will distribute itself according to the resistances. So let's call this I1, let's call this I2 and let's call this I3. So I1 is the current flowing through R1, I2 is the current flowing through R2 and I3 is the current flowing through R3. Now since the potential across each of the resistor is the same, so now let's calculate I1, I2 and I3. So I1 will be equal to V upon R1 and V is given as 12 volts and R1 is equal to 5 ohms. So I1 will be calculated and it will be equal to this 12 when divided by 5. So 5 2s are 10 and 5 4s are 20. So I1 will come equal to 2.4 amperes. Then we need to calculate I2. This is students the A part. Now we could have calculated this initially, that we can solve this problem by calculating I1, I2 and I3 first, then we can calculate the total current and then we can calculate the equivalent resistance also. So here I2 will be equal to V upon R2, so V is 12 and R2 is 10. So the total current will be 1.2 amperes. That is, the current flowing through resistor R2 is I2, which is equal to 1.2 amperes. Now we need to calculate I3. So I3 will be equal to V upon R3. So this will become equal to 12 upon 30. So this will come out to be 0.4 amperes. Now students, if we calculate and we solve the numerical problem with part A. Now here what I did was, first I solved part C, then I solved part B and then I solved part A. Why did I do so? So that you know how to calculate the total current using this formula. Now what we can do is, we can first solve the problem A which was asked, then I can calculate I1, I2 and I3. Then for part B, I can calculate the total current flowing through the circuit by simply adding these three. So if I add 2.4, 1.2 and 0.4, again I am going to have I is equal to 4 amperes. Then what I could do is, then I could calculate the C part which was the equivalent resistance and we could calculate it as I calculated it. So you can do the numerical problem as you wish. I have shown you both the ways so that you can understand how to solve a numerical problem. Now students, let's see the next problem, which is example 12.9. Now if in figure 12.12 R1 is 10 ohms, R2 is 40 ohms, R3 is 30 ohms, R4 is 20 ohms and R5 is 60 ohms and a 12 volt battery is connected to the arrangement. Calculate the total resistance in the circuit and the total current flowing in the circuit. Now students, here the values are given as 10, 40, 30, 20 and 60. 10, 40, 30, 20 and 60. Now let's see the arrangement. Now here we have R1 and R2 connected in parallel. Now the values for R1 and R2 is 10 and 40. So this is 10 ohms and this is 40 ohms. So what we see is that R1 and R2 are connected in parallel. Then we have R3, R4 and R5. These three are also connected in parallel. So let's see their values. The values are 30, 20 and 60 ohms. This is 30 ohms, this is 20 ohms and this one is 60 ohms. So these three are also connected in parallel and the equivalent resistance of these two resistors is connected in series with the ammeter and to the equivalent resistance of these three resistors. What I want to say here is, बच्चों यहाँ पर हम क्या देखते हैं कि ये दोनों पैरेलल में है, इनका इक्विवेलेंट रेजिस्टेंस, और ये तीनों जो पैरेलल में है इनका इक्विवेलेंट रेजिस्टेंस, इसका इक्विवेलेंट रेजिस्टेंस और इसका इक्विवेलेंट रेजिस्टेंस जो है वो सीरीज में कनेक्टेड है इस 12 वोल्ट की बैटरी के साथ में. बैटरी कितने वोल्ट की है स्टूडेंट्स? 12 वोल्ट की बैटरी है. तो हम यहाँ पर सबसे पहले क्या करेंगे, इन दोनों का इक्विवेलेंट रेजिस्टेंस निकालेंगे, फिर इन तीनों का इक्विवेलेंट रेजिस्टेंस निकालेंगे और फिर दोनों को सीरीज की तरह ऐड कर देंगे. तो हम मान लेते हैं कि इन दोनों का इक्विवेलेंट रेजिस्टेंस जो है वो R डैश है और इन तीनों का इक्विवेलेंट रेजिस्टेंस जो है वो R डबल डैश है. तो हम इस सर्किट का इक्विवेलेंट सर्किट जब ड्रॉ करते हैं स्टूडेंट्स, तो उसको हम ऐसे 3 पैरेलल लाइन से शो करके और हम इसका इक्विवेलेंट रेजिस्टेंस सर्किट ड्रॉ कर सकते हैं. ये हमारा अमीटर हो जाएगा और यहाँ पर हमारे पास में 12 वोल्ट की बैटरी है और ये इक्विवेलेंट रेजिस्टेंस हो जाएगा इस कॉम्बिनेशन का. तो इसको हम नाम दे देते हैं R डैश और इसको हम नाम दे देते हैं R डबल डैश. ये 12 वोल्ट की बैटरी हो गई. यहाँ पर की भी लगी हुई है स्टूडेंट्स, ये की भी लगी हुई है और एक अमीटर लगा हुआ है. तो 12 वोल्ट की बैटरी के क्रॉस ये R डैश और R डबल डैश, ये दोनों क्या हो जाएंगे स्टूडेंट्स? ये दोनों सीरीज में हो जाएंगे. तो हम नेट इक्विवेलेंट रेजिस्टेंस जो है उसको हम R कह देंगे और वो जो R होगा वो R डैश प्लस R डबल डैश होगा, क्योंकि R डैश और R डबल डैश दोनों सीरीज में कनेक्टेड हैं. तो इसको सॉल्व करते हैं स्टूडेंट्स. सबसे पहले 10 और 40 का पैरेलल कॉम्बिनेशन सॉल्व करते हैं, फिर 30, 20 और 60 का पैरेलल कॉम्बिनेशन सॉल्व करते हैं. तो 10 और 40 ये हमारे पास में है. तो हमारा R डैश जो है स्टूडेंट्स वो हो जाएगा 1/10 प्लस 1/40. So the LCM will be say 40. We can take the LCM as 40. So here I'll have a 4 plus 1. So this will come out to be 5/40. 5 ones are 5, 5 eights are 40. So this is 1/8. So R dash is equal to 8 ohms. Now I will calculate R double dash, which is the equivalent resistance of these three, and these three are 1/30 plus 1/20 plus 1/60. So here the LCM can be taken as 60. So if I take the LCM as 60, then 32s are 60, 23s are 60 and 61s are 60. So 3, 4, 5 and 1, 6. So I'll have a 6/60, which will give me 1/10. So R double dash comes out to be 10 ohms. So now students, the total resistance, the total equivalent resistance of these two combined in series, which we took as R. So R will be equal to R dash plus R double dash. So what we will have? The total equivalent resistance of the circuit will be 10 plus 8. 8 plus 10, which is equal to 18 ohms. So the net equivalent resistance of the circuit is 18 ohms. So we have solved the part A of the numerical problem, and the next part, what is asked? We need to calculate the total current flowing through the circuit. So let's calculate the total current flowing through the circuit. So the total current flowing through the circuit will be calculated by using Ohm's law. So V is equal to IR. So I will be equal to V upon R. Now V is given as 12 volts and R we have calculated as 18. So this can be cancelled by a 6. So 6 2s are 12 and 6 3s are 18. So we need to divide 2 by 3. So students, if we divide 2 by 3, then I'll put a decimal over here. I'll have a 20. 3 6s are 18. Again I'll have a 20. 3 6s are 18, and again I'll have a 20, and so on. So this can be taken as, the current can be taken as 0.667 amperes. So this will be the total amount of current flowing through this circuit. So this is the solution for the B part. This is the solution for the B part, students, and this is the solution for the A part. Now let's see the next problem. Judge the equivalent resistance when the following are connected in parallel. Now students, here we have two resistances. In the A part, we have two resistances of 1 ohm and 10 to the power 6 ohms. They are connected in parallel. So let's solve this. And in the B part, we have three resistances, 1 ohm, 10 to the power 3 ohms and 10 to the power 6 ohms. Then we will solve this part. So in order to solve solution of part A, what we have is, we have two resistances. So the formula for the equivalent resistance will become 1 upon R1 plus 1 upon R2. So what we will have? 1 upon 1 plus 1 upon 10 to the power 6. Now we will take the LCM, and the LCM will be 10 to the power 6. So here I will have 10 to the power 6, and here I will have a 1. So if 1 is added to 10 to the power 6, then it is nearly equal to 10 to the power 6 only. So this can be taken as nearly equal to 10 to the power 6 upon 10 to the power 6, which is nearly equal to, say, 1. So the reciprocal of this will again be 1. So what we see here, students, is that the equivalent resistance comes out to be nearly equal to 1 ohms. So let's solve the next part. And in the next part, we had three resistances, and the three resistances were, so we will write the formula for the equivalent resistance, and the three resistors were, one was 1 ohm, the other was 10 to the power 3 ohms, and the third was 10 to the power 6 ohms. So when I take the LCM over here, it will be 10 to the power 6, here I will have a 10 to the power 6, here I will have a 10 to the power 3, and here I will have 1. So what I get is, students, 10 to the power 6, here I will have 1, 2, 3, 4, 5, 6 zeros plus 3 zeros, 1000, and plus 1. So if I add this, students, then what I will get is 1 0 0 1 and then 0 0 and again a 1 upon 10 to the power 6. So students, on taking reciprocal, what I get is, so on taking reciprocal, what I get is, students, that the equivalent resistance R is equal to 10 to the power 6 upon 1 0 0 1 0 0 1, which is nearly equal to 0.999 ohms. So the equivalent resistance of these three resistances comes out to be 0.99 ohms. So what we see is, if 1 and 10 to the power 3 ohms of resistors are connected in parallel, then their equivalent resistance comes out to be nearly equal to 1 ohms. And if 1 and 10 to the power 3 and 10 to the power 6, three resistors are connected in parallel, then their equivalent resistance also comes out to be nearly equal to 1 ohms. Now let's see the next problem. Question 2. An electric lamp of 100 ohms, a toaster of resistance 50 ohms and a water filter of resistance 500 ohms are connected in parallel to a 220 volt source. Here we have three things: a lamp, electric lamp of 100 ohms, a toaster of 50 ohms and a water filter of 500 ohms. These all three, 100 ohms, 50 ohms and 500 ohms, are connected to a 220 volt supply. Now what is the resistance of an electric iron connected to the same source that takes as much current as all the three appliances, and what is the current through it? Now students, here we need to calculate the equivalent resistance of these three appliances. Since what is said that a electric iron is connected to the same source, that is the potential is 220 volts for the electric iron also, and it takes as much current as all the three appliances collectively take. So first we need to calculate the equivalent resistance of these three appliances, which are simply resistors. So we have 100 ohms, a 50 ohms and a 500 ohms. So first let's solve this. So for the solution, first what we will take is, we will calculate the equivalent resistance of, first we had a 100 ohms, then we had a 50 ohm appliance, and then we had a 500 ohm appliance. So when all these three are connected in parallel, then the equivalent resistance of these three resistors is given by, say, R. Then the formula will be like this. Now on taking LCM, the LCM here will be 500, 100 5s are 500, 50 10s are 500 and 500 1s are 500. So I will have a 16 upon 500. Now this is 1 upon R. Now for calculating R, we will take the reciprocal and the equivalent resistance will come out to be 500 upon 16. Now this can be solved further. Initially let's cut it by a 2. So 2 8s are 16, 2 2s are 4, 2 5s are 10. Again I can cut it by 2, 2 4s are 8, 2 1s are 2, 2 2s are 4 and 2 5s are 10. So the equivalent resistance is 125 upon 4. Now this is the equivalent resistance of these three resistors connected in parallel. Then the voltage supply was 220 volts. So we can calculate the current as V upon R. So V is 220 volts and the resistance is 125 upon 4. So this 4 will go upwards. So if I cancel out this, then this can be done by calculating, this can be cut by, this can be divided by 5. So I will have a 5 2s are 10 and 5 5s are 25, 5 4s are 20 and again 5 4s are 20. So what I get is here 4 4s are 16, 4 4s are 16, 176 upon 25, and here I had 125 upon 4. So let's solve this further so that we get a proper decimal value. So the resistance can be calculated as, it is 125 upon 4. So 4 3s are 12, left with a 5. So 4 1s are 4. Now putting a decimal over here, I will get a 10, 4 2s are 8, I am left with 20. So 4 5s are 20. So what I get is that the resistance, the equivalent resistance comes out to be 31.25 ohms. So R is 31.25 ohms. Now first let's calculate this, the value of current also. So the equivalent resistance came out to be 31.25 ohms. Now we need to calculate the value for current. So on dividing 176 by 25. 25 sevens are 175. So I am left with a 1. On putting a decimal, I'll have a 0 over here. Again, I'll put a 0. So I'll have a 100. So 25 fours are 100. So the current in the circuit comes out to be 7.04 amperes. So this is the solution of the numerical problem. The equivalent resistance comes out to be 31.25 ohms and the current comes out to be 7.04 amperes. Now let's see the next problem. What are the advantages of connecting electrical devices in parallel with the battery instead of connecting them in series? Now here हमें यहाँ पर ये पूछा है बच्चों कि हम जो है क्या एडवांटेज लेते हैं कि हम इलेक्ट्रिकल डिवाइसेस को पैरेलल में कनेक्ट करते हैं, मतलब कि हम पैरेलल में क्यों कनेक्ट करते हैं इलेक्ट्रिकल डिवाइसेस को, क्या कारण है कि हम उन्हें सीरीज में नहीं कनेक्ट करते हैं और पैरेलल में कनेक्ट करते हैं. सो द आंसर विल बी रिटन लाइक दिस. There is no division of voltage among the appliances when connected in parallel. The potential difference across each appliance is equal to the supplied voltage. यहाँ पर हमने क्या बताया स्टूडेंट्स कि हर एक इलेक्ट्रिकल अप्लायंस को 220 वोल्ट की सप्लाई जो कि हमारे घरों में होती है 220 वोल्ट्स की सप्लाई मिलती है, यानी कि वो 220 वोल्ट्स जो है वो अनडिवाइडेड बिना बटे हुए हर एक इलेक्ट्रिकल अप्लायंस को मिलता है अगर हम उसे पैरेलल में कनेक्ट करते हैं. और अगर हम सीरीज में कनेक्ट करते तो जो 220 वोल्ट्स है वो डिस्ट्रीब्यूट हो जाता, यानी किसी को तो मिलता सपोज करो 100, किसी को मिलता, दूसरे को 50 और बाकी बचा हुआ मिलता तीसरे को. तो यहां पर हमने क्या किया, अनडिवाइडेड 220 वोल्ट सभी को एक जैसा मिले उसके लिए हम पैरेलल सर्किट कनेक्ट करते हैं. और हम क्या लिखेंगे स्टूडेंट्स, द टोटल इफेक्टिव रेजिस्टेंस ऑफ द सर्किट कैन बी रिड्यूस्ड बाय कनेक्टिंग इलेक्ट्रिकल अप्लायंसेस इन पैरेलल. तो हम क्या करते हैं स्टूडेंट्स, जब हम इलेक्ट्रिकल अप्लायंसेस को पैरेलल में कनेक्ट करते हैं तो जो उनका इक्विवेलेंट रेजिस्टेंस है वो कम हो जाता है. हमने देखा था ना स्टूडेंट्स, अभी थोड़ी देर पहले हमने किया था कि अगर हम रेजिस्टेंसेस को पैरेलल में कनेक्ट करते हैं तो इक्विवेलेंट जो रेजिस्टेंस की वैल्यू आती है वो मिनिमम रेजिस्टेंस से भी कम होती है, यानी कि सभी रेजिस्टेंसेस जो कनेक्टेड हैं उनसे कम होती है इक्विवेलेंट रेजिस्टेंस की वैल्यू. तो इसलिए ये रीजंस हैं कि हम पैरेलल सर्किट कनेक्ट करते हैं इंस्टेड ऑफ सीरीज सर्किट. राइट स्टूडेंट्स, लेट्स सी द नेक्स्ट प्रॉब्लम which is question number 4. How can three resistors of resistances 2 ohms, 3 ohms and 6 ohms be connected to give a total resistance of 4 ohms and 1 ohm? अब यहाँ पर स्टूडेंट्स हमें 3 रेजिस्टेंसेस दिए हुए हैं, 2 ohms, 3 ohms और 6 ohms. और इनसे हमें क्या बनाना है, एक 4 ohm का रेजिस्टेंस या फिर एक 1 ohm का रेजिस्टेंस. तो हम यहाँ पे क्या देखते हैं स्टूडेंट्स कि अगर 2 ohm के अंदर मैं एक और 2 ohm प्लस कर दूं तो मुझे क्या मिल जाएगा, 4 ohms मिल जाएगा. तो यहाँ पर ऑब्जर्व करने से मुझे ये दिख रहा है कि 3 ohm और 6 ohm को अगर मैं पैरेलल में कनेक्ट कर दूं तो शायद मुझे 2 ohms का रेजिस्टेंस मिल जाएगा. यस, ये प्रैक्टिस से आ जाता है स्टूडेंट्स कि देखने से ही फिगर थोड़ा सा आइडिया लग जाता है. तो यहाँ पर हमें समझ में आ रहा है कि 3 ohm और 6 ohm को तो मैं पैरेलल में कनेक्ट कर दूं और उसके इक्विवेलेंट को 2 ohm के सीरीज में कनेक्ट कर दूं तो मुझे 4 ohms का एक नेट इक्विवेलेंट रेजिस्टेंस मिल जाता है. तो पार्ट ए के लिए स्टूडेंट्स मैं एक 2 ohm के रेजिस्टेंस को कनेक्ट कर दूंगी 3 ohms और 6 ohms के पैरेलल कॉम्बिनेशन के साथ. तो ये हो जाएगा 3 ohm का रेजिस्टेंस, ये हो जाएगा 6 ohm का रेजिस्टेंस और ये हो जाएगा 2 ohm का रेजिस्टेंस. तो इनका जो इक्विवेलेंट रेजिस्टेंस आएगा वो 4 ohms आएगा. कैसे आएगा स्टूडेंट्स, पहले इन दोनों का इक्विवेलेंट निकालूं. तो इन दोनों का इक्विवेलेंट सपोज करो मैंने नाम दे दिया R डैश, तो वो कितना हो जाएगा 1/3 प्लस 1/6. तो अगर मैंने LCM लिया 6 तो 3 2 ज़ा 6 और यहाँ पे 1, तो ये हो जाएगा 3/6 यानी कि 1/2। तो यानी कि इन दोनों का इक्विवेलेंट रेजिस्टेंस कितना आ गया? 2 ओम्स। अब ये 2 ओम्स और ये 2 ओम्स जो है ये कैसे कनेक्टेड हैं? ये सीरीज में कनेक्टेड हैं। तो हम इसका एक और इक्विवेलेंट रेजिस्टेंस जो है, इक्विवेलेंट सर्किट डायग्राम ड्रॉ कर सकते हैं। तो इसका जो इक्विवेलेंट सर्किट डायग्राम होगा स्टूडेंट्स, वो इस तरीके से हो जाएगा कि ये तो हो गया 2 ओम्स और ये हो गया इक्विवेलेंट रेजिस्टेंस इन दोनों का, जिसको हमने नाम दिया R डैश। तो ये हमारा 2 ओम्स का रेजिस्टेंस है और ये R डैश हो गया जो हमने कितना निकाला? 2 ओम्स। तो यानी ये दोनों कैसे कनेक्टेड हो गए? सीरीज में कनेक्टेड हो गए। तो जो नेट इक्विवेलेंट रेजिस्टेंस है वो हो जाएगा 2 + 2 यानी कि 4 ओम्स। अब बी पार्ट के सॉल्यूशन में हमें क्या चाहिए था? हमें चाहिए था कि इनको मैं कैसे कनेक्ट करूं, 2 ओम, 3 ओम और 6 ओम को, कि मुझे 1 ओम मिल जाए। तो मैं तीनों को पैरेलल में कनेक्ट कर दूंगी। सो बी पार्ट के लिए अगर तीनों रजिस्टर्स पैरेलल में कनेक्टेड हैं, तो एक रेजिस्टेंस तो हमारे पास में क्या था? 2 ओम्स का, एक था 3 ओम्स का और एक था 6 ओम्स का। तो 1/2 + 1/3 + 1/6। एलसीएम लेने पे स्टूडेंट्स 6 आएगा, 2 3 ज़ा 6, 3 2 ज़ा 6 एंड 6 1 ज़ा 6। सो 1/R हो जाएगा 6/6 यानी कि 1। तो R जो इक्विवेलेंट रेजिस्टेंस है वो हो जाएगा 1 ओम। So the answer will be that in order to get 4 ohms of equivalent resistance, we'll connect 3 ohms and 6 ohms in parallel and a 2 ohm resistor in series with them. And in order to get a 1 ohm equivalent resistance, we will connect all the 3 resistors in parallel. Now let's see the next problem, which is question number 5. What is the highest and the lowest total resistance that can be secured by combinations of 4 coils of resistances, 4 ohms, 8 ohms, 12 ohms and 24 ohms. यहाँ पर स्टूडेंट्स हमें इन 4 रेजिस्टेंसेस से 4 कॉइल्स दी हुई हैं जिनका रेजिस्टेंस दिया हुआ है। तो इन 4 रेजिस्टेंसेस का ऐसा कॉम्बिनेशन बनाना है कि हमें एक बार तो हाईएस्ट रेजिस्टेंस मिले और एक बार लोएस्ट रेजिस्टेंस मिले। सो स्टूडेंट्स यहाँ पर हमें ये याद रखना है कि जब रेजिस्टेंसेस को सीरीज में कनेक्ट करते हैं तो हमें हाईएस्ट रेजिस्टेंस मिलता है, और जब रेजिस्टेंसेस को पैरेलल में कनेक्ट करते हैं तो हमें लोएस्ट रेजिस्टेंस मिलता है। तो यहाँ पर हम क्या करेंगे? एक बार तो चारों को सीरीज में ऐड करके इक्विवेलेंट निकाल लेंगे और एक बार चारों को पैरेलल में कनेक्ट करके इक्विवेलेंट निकाल लेंगे। तो पहले क्या करेंगे? हाईएस्ट के लिए हम क्या करेंगे? सीरीज में कनेक्ट करेंगे। सो इसका सोल्यूशन स्टूडेंट्स कैसे लिखेंगे? फॉर highest resistance all coils should be connected in series. So what we get is the equivalent resistance will be equal to 4 plus 8 plus 12 plus 24. So what will be the equivalent resistance? The equivalent resistance will be 48 ohms. So this will be the highest resistance from these 4 coils. They will be connected in series. Now what we need is, we need the lowest resistance, and for lowest resistance these all 4 will be connected in parallel. So what we will write? You will write that for lowest resistance all coils should be connected in parallel. Right students? So this 4, 8, 12 and 24 will be connected in parallel. So the solution for the lowest resistance we will write for lowest resistance all coils should be connected in parallel. So if I connect all the 4 in parallel, then the equivalent resistance will be equal to 1 upon 4 plus 1 upon 8 plus 1 upon 12 plus 1 upon 24. Now the LCM can be taken as 24. Now 4 6 are 24, 8 3 are 24, 12 2s are 24 and 24 1s are 24. So what I will get is, we will get a 12 upon 24. So 1 upon R will be 12 upon 24, which can further be solved as 1 upon 2. So the equivalent resistance will be 2 ohms. So this will be the highest resistance which we can take out of the 4 coils, and this is the lowest resistance which we can take by these 4 coils. So students, today we solved all the in-text exercises based on parallel combination of resistors. Now in our next part we will study about the heating effect of electric current. Till then, stay safe, stay healthy, bye-bye.